All right, first derivative test. Suppose that c is a critical number of a continuous function. If the derivative changes from positive to negative at c, then we know f has a local maximum there. Here's an example of that. If it turns positive to negative, that's going to have to be a max if as long as it's continuous and that point's not a corner. If it changes from negative to positive, then this is going to be a local minimum. If f does not change signs at c, for example, if it's positive on both sides or negative on both sides, then it's not a local max or min. Here's some examples where it just levels out and then goes here. That's not a max or min. If it's negative, turns 0 and goes negative again, that point's not a max or min either. So it has to change signs there. Let's look at an example here where they're trying to ask us to find those local max and min points. So first thing we need to do, find those critical numbers, find the derivative. So derivative of g here. Now this one has some trig, but that's okay, we can do it. Derivative of x is 1. Derivative sign is cosine, so this will be 2 cosine x. All right, now we got to figure out where that equals 0 or does not exist. Put that equal to 0 to do that. To solve this, let's minus 1. And then let's divide by 2. So now it's where does cosine x equal negative 1/2. We can come up with that value by doing some inverse here. So I'm gonna do it in degree mode first, even though we're gonna have to answer in radians eventually here. I'm gonna start with this. I think most of you are more comfortable with degrees. So if we do inverse cosine to find this now, to figure out what x equals, let's do inverse cosine. That would give us negative 1/2. Here we get 120. So one answer here is 120 degrees. How far do we need to keep going? Well, we went between 0 and 2 pi, or 0 and 360 degrees. There's probably another answer on here that we need to find. So think about our unit circle. We know that cosine here, if we got cosine, we're talking about the x value, because cosine is x, sine is y value. 120 gives us one answer. So if we travel around the circle, there's 90. 120 is going to be 30 more degrees after that. So 120 degrees is one answer. Where do we get another answer that has that same x value? Down here. So to get that one, we would want to travel around the circle an equal amount, 120 the other way. Well, that would be negative 120. What's that same angle though if we started here and went all the way to there? You can get that one by doing 360 minus 120, or 240 degrees. So the two answers here that we want is 120 and 240. However, we do want to be here in radians, as we can see, so now we need to convert those over. Remember, our conversion is to do pi over 180, so we want to do 120 times pi over 180. Now simplify that down and see what you get. Here, if you divide them both by tens, or divide both by tens, that's 12 pi over 18, and I think 6 goes into both of those, so we get 2 pi over 3 would be one answer, or one critical value. Do the same thing on the other ones. The other one, 240 over 180. Again, knock out the zeros. 6 goes into both 24 and 18, so that one would be 4 pi over 3. So those are our two critical numbers there. Now, to see where it's increasing, decreasing, to determine if those points are max and min, do like we did with the increasing, decreasing stuff. Put those two on here and see what the slopes are doing going into those points. One lesson that we could test would be like a 0. So what would we get if we put 0 in for our angle here. I am going to go back now to, let's go back to our radian mode here. Check these because we're going to be doing stuff in there. So putting it into our derivative now because we want to test slope. 1 plus 2 cosine 0, cosine 0 comes out, cosine 0 comes out to be 1, so 2 times 1 is 2 plus 1 is 3. So that comes out to be positive over here. We got positive slope. Something in between 2 pi and 4 pi over 3 in between this point and this point would be like pi. So let's check pi next. What do we get if we do that one? That one should come out to be -1 because cosine pi here should be -1 and timesing it by 2 and then adding 1 gives us -1. So this comes out to be negative. And then we need something bigger than 4 pi over 3 to test. Like if we kept going around the circle here, 2 pi, which is the same as 0, so that should give us the same result, would be positive. And so we can see here if it's increasing positive slope into decreasing, that makes this a maximum value. If we're decreasing and then increasing, that's going to make this value a minimum value. So you can find out local mins and maxes by using the slope.